networking devices: hub, switch, router, modem. Mainly four devices we use. Other devices like repeaters. Bridge is not a device anyway, but concept of bridging is also somewhat. Firewalls, IPS IDS, VPN servers or VPN connectors or VPN mixed with other things is also there. As yesterday, I think I gave you some links for in a morning session for a power set kind of stuff. Okay, so that is animated videos. In that one also, I shared a links about these things. So please go through once again. It's a short form of notes kind of stuff like what is a hub. It is useful for a small network. LAN communication switch is used for LAN network only. Small and large networks, it is also do MAC learning. Router used for both LAN and WAN communication. Both side it will work. LAN to LAN, LAN to WAN communication. Internetworking device. What is internetworking? Communication between two or more networks. And it shows best path to reach the destination. I open a google.com. The google.com located in somewhere. But how to reach the google.com? For example, I have to go to Delhi. How to reach Delhi? Which path is best path? Like that. Same way, I want to reach google.com. Which path is best path? That will tell by our routers only. Modem connects to internet, ISPs, internet service provider via using telephone lines or optical fiber cables or WAN cables. Okay, so that is a modem device. Repeater, it repeats the signal, so then you can communicate. And why it is signal becomes singles? Signal becomes singles. Signal, right? But repeat the signal to communicate long distance. For example, our cable support up to 100 meters. So I use a repeater. So I can communicate a little extra long distance, like maybe a 150 or 100, 150 or 180 or 200 kind of distance, total distance, you can able to communicate. Okay. Repeater is a repeat the signal. It don't boost the signal. It just again further. So we can use hub as a repeater, and there is a repeater devices also there. Bridges are software based, not a physical bridges are not there. Okay. Of course, some physical bridges like a routers kind of stuff is also there. Not I'm not doing that one anyway. So bridges is a mainly I want to understand, make you to understand. You have two NICs and you want to make it as a bridging. Easy to understand, guys. You have a mobile phone with 4G internet data and you want to share internet via your Wi-Fi network, mobile Wi-Fi, you want to share it to your friend or someone. That is called a mobile hotspot. How to share a data, your mobile data to others, internet to others, hotspot. So what you are doing, you are bridging your mobile data, that connectivity chip to that NIC to your Wi-Fi NIC. You are bridging there. Okay, so like this is the bridging concept. Connecting, bridging between two different networks, bridging between NICs and other devices like a firewall, protect your network from external attacks. VPN is make a connecting or the internet, make a connection or the internet which we can able to access our infrastructure through VPN server. IDS, IPS, institution detection system, institution prevention system. Someone is enter into your network, so it will detect that the system is detect if someone is came unauthorizedly into your network. It detect that network, a packet. This is some intrusion is happen. Prevention. So it is not does not it is prevent to not to enter inside. Okay, guys. Here it is devices. Okay, hub and repeaters. So already I showed this picture, hub picture and this picture also. But again I will try. So networking hub. Last batch, one batch, they confused between the questions and answer part. Okay, so what happened? Hub is there, UDP is there. So there's a question line. So in the question line, when they share the questions, UDP, what is UDP, what is hub, what is switch, what is router. Again, they forget what is UDP. UDP is a TCP UDP concept. Okay, the protocol concept. So they immediately think when I'm telling about hub switches kind of stuff, because of this question is there, they're asking like, sir, there is a UDP question is also there. Tell me about the UDP device. Don't get confused, guys. If you are to avoid a confusion, B, put your mind in active stage, not a switch off condition. Yeah, hub is a non-intelligent device. It does not understand your system MAC address or a IP address concept. There's some points are there, guys. So, but what are the highlighted? Please compulsory put a pin on it. Other points you can read it. No problem. Of course, other points also important, but these some points why I'm not highlighted or I highlighted some points is the main means at least to list these important ones. The hub is not a intelligent device. It is a simply wiring part. It does not understand MAC address or a IP address. Where we use hub, of course, star topology, we are using it. Next, it broadcasts a packet to everyone in the network. You can see here it is. This PC want to communicate to someone, but it is broadcast to everyone. I'll show you a picture, guys. See it is. This is hub and connected to the devices. A want to send a packet to C. A want to send a packet to C. A send a packet to hub, hub to C, and hub to D, hub to B, hub to Z. It means not only to C, the packet is also sent to other devices. Other devices will drop the packet because to and from address is different, right? So the to address is for packet is for C and received by D. What it will do, drop the packet. The C device will accept the packet. So one time no problem, but multiple times means B want to communicate it to D. Packet sent to A, G, D, C. Like every time it broadcasts to all the packet to every device. So what happen? Lot of traffic is increases. Number of collisions will occur. So packet data loss will occur. Packet data loss will occur. Okay. It broadcasts the packets to everyone the network. Those who are connected in the network, they will get the packet. Used for LAN communication, suitable for a small networks. So you have a 4 computers, no problem. You have a 50 computers, there is a big problem. Okay. So 4 computers, no problem. 50 computers, big problem. Understand? Small networks. It is also called as a layer 1 device. And as per OS layers, it is a layer 1 device, means it's a physical layer device. Okay. It repeats. Okay. So repeater. I have written about a repeater here without separately. Repeater repeat the signal again, so then signal can send to long distance. Hub act like a repeater sometimes. Example of repeater also you can say about a Wi-Fi extender. You know, I'm showing how repeaters look like. You can use hub as a repeater or a repeater device is also there. If there is a different distance between one network to another network is there, it's difficult to travel from there to this distance. We use a repeater to repeat the signal. This is different repeater. Okay, so normal repeaters are shown on that picture like this. This is a Wi-Fi extension. Wi-Fi extender also is a repeater. Wi-Fi extender is also a repeater. So why? Because you are away from the Wi-Fi router. You are you are having a Wi-Fi router. Okay, you have a Wi-Fi router. If you are near to the Wi-Fi router, then you will get a very good signal, right? So you will get a all good signal kind of. You have a distance. If you are very far, okay, so your device will get a 1 point kind of stuff. You can show. I will show you some points here. I'll try. See it is. So only one dot is there. Signal is receiving, but not having strength signals. No strength the signals. So 1 point is there. 1 point is there. 1 point is there, and no point is there. And here it is. 2 point signal is there, which is near far. Okay. I think so. You got the point, guys. So if you are having a distance, or you are sitting in a different room or glass door kind of stuff, signal will be very less. Okay. Now here it is. I put this Wi-Fi extension. But what is this Wi-Fi extension will happen? It receive a signal. So here it is a borderline, almost like a this is from here the signal become weak. From almost like here it is almost like a edge. Signal become weaker. Then what I will do? So I will do. Okay. What I will do? In between this Wi-Fi router and a user, so I will check the distance. Then I put a repeater. This repeater, anyway, this is Wi-Fi extension. This is radiate the signal. So it will receive the signal. That's why I remove that point. It receive the signal first, and again it will forward the signal. It means what happened? So you will get a very good strengthy signal. Earlier you are getting a very weak signal, like 1 point you are getting. Now you are getting full Wi-Fi signal. Why? Because of this Wi-Fi extension. It receive the signal and again repeat the signal. So then we are getting the signal. So which password we have to use it? Your Wi-Fi password only. We are connecting to your Wi-Fi only. We are connecting to your Wi-Fi only. But we are communicating to your Wi-Fi via this Wi-Fi extension. Okay. So your Wi-Fi extender is also an example for a repeater. Okay, remember that, guys. Simplest thing is what you know, what you have, what you are learn, what you seen. Those are very important than what you don't know, what is something which is you have never seen kind of stuff. Like, have you seen a router kind of stuff, real-time router? Have you ever configured a router? Have you see the firewall kind of stuff maybe? But in your home, you've seen a Wi-Fi router. You've seen a cable connection. You may have seen the how to connect a Wi-Fi router. You have seen the LEDs on your router. Okay. That is what you have a minimum knowledge. In college, you may see in the lab, you may see in the multiple computers, cable connectors. That is the main important. Okay. What you not seen or never seen, it's just the only it is a word. That is the secondary. Repeater repeats the signal. So signal can send long distance. Hub act like a repeater. Repeater Okay, so example, we can also say in a latest device, Wi-Fi extender. Okay, guys, again, what is a hub? Hub is a device, non-intelligent device, does not understand MAC address and IP address. Very importantly, we use a hub in the LAN communication suitable for a small networks only. You know why it is? Because it broadcasts a packet to every device in the network. Not everyone in the network, you have to tell every device in the network. Every device in the network, those who are connected in the network, they'll get the packet. Okay. It is a layer 1 device as OS layers. It's a layer 1 device. It's a physical layer. Because of it is broadcasting to every device in the network, number of collisions occur, packet data loss. That's why it is not suitable for large networks. So those many points, if you cannot remember, what are the points I told? The base points, please tell that one. Guys understand hub and Wi-Fi extender, repeater.
So,
Response.
yes, sir. Understood.
Next device is switch. The switches are intelligent device, not very intelligent device, but there is some intelligence inside. Okay, it can understand MAC address. Okay, so if switch can understand MAC address and it will do MAC address table. It will learn the MAC address of devices. So whenever you connect a computers, you are connected computers to your switch. So when they are communicating each other, each computer is communicating each other, it will learn the device means computer MAC address, which can able to which can able to learn MAC address of a device. Okay, that is the simplest. So switch is an intelligent device. Okay, it maintains a MAC address table by learning MAC addresses of devices, and it create a table with a switch port number, switch port number, and device MAC address wise. Initially, the switch broadcast like a hub, like a sending a packet to every device in the network. Initially, it will do, but later it is do unicast means A want to send a packet to B, so the packet sent to B only. That kind of stuff. Okay. So again, switch is intelligent device. It maintain the MAC address table with MAC address of device and port number of switch. Like that is a MAC address table. We use for LAN communication only. It is a layer 2 device, data link layer as per OSI. We use switches for both small network and large networks also. Okay, so it is initially broadcast, but later it is unicast. So number of collisions are less, so less packet data loss. That's why we can able to connect large number of devices. Also, the switches generally 8 port switches, 4 port switches, sorry, 8 port switches, 16 port, 24 port, okay, 48 port, like a big switches also there, 72 port. Okay. So big switches, small switches also available. So that's it is small and large networks. We can use it. Of course, switches and hubs are star topology devices, right? This is a direct star topology device. So we can connect one switch to another switch. So then we can create a large, we can connect a large number of devices in the single network, the large networks. So what is the function of switches? Like forwarding the packets, of course, MAC address learning and forwarding of packets. There's a different type of switches also there, like a cut through, store and forward switches, full duplex communication kind of stuff. Yes, there is small point. It is there is a L3 switches. If you got a question in confidently, sir, switches are L2 switches only because it's a layer 2. Layer 2 means MAC address, so it is a layer 2 switch. Yeah, I will discuss. We will discuss OS layer later, guys. But to just note that point only. So there is a layer 3 switches means as per OSI, layer 3 is a network layer. Routers are a layer 3. Layer 3 device is router. But layer 3 switch means it do function as a switch as well as a router. As a switch, we can do the MAC address tables. Um, VLAN techniques are there. VLAN, virtual LAN communication, virtual LAN. So you create a virtual LAN, means physically it is single LAN, but virtually we can divide a single LAN into multiple LANs. Want to communicate between that one, so that is inter VLAN routing, VTP kind of stuff. Okay, inter-network communication we can do in the L3 switches. Means L3 switches work like a switch as well as a router functions. Just a point only, guys. That's not a very trust point. Okay, but you got the point. That is good. Okay. L3 switches. Okay, so switch is L2, but there is a L3 switches. L3 switches do both switch and router function. The L2 switches only do switch function. Again, switch is an intelligent device. It learn MAC address of a devices and maps to the port number of um, switch port and create a MAC address table. Switch use it for LAN communication, both small and large networks. Okay. A number of devices we can connect, means large number of devices also we can connect. It's a layer 2 device and number of collisions are less and less packet data loss using switches is compared to hub. Initially it work like a broadcast like a hub, but later it is become unique. See guys, here is a picture written, but I will do the picture again for our understanding. This is a switch. These are computers or devices, whatever the name you put it. Computer means computer. Devices means it can be a computer or a laptop, or it can be the computer and laptop both are same, of course. Or it can be a printer. Okay, like that. Computer means it's a computer or laptop or a system, PC, anything. Guys, here it is. You have a, if you see, this switch having a ports, right, for connecting with wire. Each port having a number 1, 2, 3, 4, 5, 6, like that. Okay. Here also I'm putting a number here. Port number 1, 2, 3, 4, 5, 6, 7. Yeah, 4 is empty and 8 is empty. Okay. This is APC. APC MAC address is A1. This is BPC. BPC MAC address is B1. Normally it is 48 bit, 12 hexadecimal, but I'm not writing so for just for a understanding. CPC C1. This is DPC D1. EPC E1. CPC, sorry, FPC F1. So these are the MAC addresses, and these are the computer names, and these are the switch port number. Now you want to communicate it to B. I use different colors here. A to B communication. A send a packet to Guys, while it is communicating, please note down this one. So means understand this one. Source MAC address. In the packet, you have a source MAC address, destination MAC address, source IP address, destination IP address will be there, right? And your packet data. The source MAC address is A1. Destination MAC address, generally we don't know the destination MAC address when you are communicating. Generally in starting you don't know the destination MAC address. Later we will learn. So forget about it. So first packet is sent to the switch, the port number 1. Correct, port number 1. So here it is, switch port number. This is port number means switch port number 1. This is MAC address of a device. MAC address. Okay. So A send a packet through 1 to the switch, then automatically lands the A's MAC address. Then packet sent to for a first time, the today first time when I switch on the switch, and this is the communication, A to B communication. A send a packet to switch to port number 2 means B, then port number 3 means C, port number 5 means D, port number 6 means E, port number 7 means F. Okay, and 4 and 8 is no device is connected means it is broadcast to everyone. It already LAN port number 1 is A. Next, so of course everyone is drop the packet, B1 is accept the packet. Okay. So it is map the already port number 1 is connected to A1. Now, for example, C1 means CPC communicated to EPC. C send a packet to switch means it is 3 port number 3, and C1 is a MAC address which is connected to port number 3, and it will try to send a packet to E1 and to everyone because initially broadcast. Okay, so finally E1 accept the packet. EPC accept. Now again, A send a packet to C1. Sorry, not C1, C. Okay, so A send a packet and to C1, right? C1 MAC address, for example, if you know the MAC address, C1 MAC address, where it is located in 3, right? It's sent to 3 directly, C receive the packet. It does not send to anyone. This is called a unicast. Of course, while there are communicating each other, or by just connecting also it will happen, while it is communicating each other by sending a packet. Automatically, your switch will run this MAC addresses of where based on the port it is connected also. Like a second one connected with B1, third one is already there, so then we'll see the fourth one is not connected to anyone. Then fifth one is connected to D1 MAC address. Sixth one device's MAC address is E1. Seventh one device is F1 MAC address. Okay, just for our understanding, guys, only. So once this MAC address table is created, for example, E want to send a packet to B. Okay, so what happened? E send a packet to switch and see the B's MAC address. B's MAC address is B1. P1 is connected to port number 2, will forward the packet to port number 2 directly. No need to broadcast. Okay. Initially it is broadcast to everyone, but by the broadcast itself, we can learn the MAC address of the devices and map to switch port numbers. Okay. This is up to here. There's a lot of so many other things also there. Like if you connect one switch to another switch, so what is the MAC address of that particular port and all. So that is a different kind of stuff. But this is basically how MAC address table work. Okay, guys, what is a switch? Intelligent device. It learn MAC addresses. It can learn MAC addresses. It maintain the MAC address table by mapping switch port number and MAC address of a device is connected to that port. We use switches for LAN communication only. It is a layer 2 device, data link layer. You can use switches for both small and large networks. Means within the LAN only. Large number of devices we can connect because of we have a large number of ports are there, and of course it is a star topology we are using, so compulsory if you can have multiple switches connect each other, so obviously more number of devices, less number of collisions, less number of packet loss in the switches. Full duplex communication is there. Okay. Of course, in switches there is a layer 3 switches. We do function as a both switch functionality, router functionality. Like a switch is LAN communication, router is a WAN communication. So it is layer 3 switches for inter VLAN routing, TP, inter networking, communication kind of stuff also used. As understand switches.
Yes, sir.
Difference between bridges and switches. Bridges are software based, switches are hardware based. Okay, so bridges generally you have a server or a computer having multiple ports. You can bridge between them or by connecting different topologies or different segments. Okay, or a routing between two devices or connecting two NICs. This is a bridging. Bridge word is very good word, guys. Compulsory remember the word bridging. Okay, bridge means connecting between two ports, two NICs, two different topologies, kind of. Switches are different. Switches are very simply can say a switch is switch. It is works in a single topology or single network. Even you connect one switch to another switch, it is become a single topology only, not a different network. And another important one is router. Again, router is also intelligent device. It understands logical addressing. Logical addressing means IP address it will support. Okay. Router is a internetworking device. Router is a internetworking device. What is internetworking device? Connection of internetwork means connection of two or more networks, and communication between two or more networks is internetworking. So when you do an internetworking, which device? Router. Used for both LAN communication and WAN communication also. Okay, LAN communication and WAN communication. So we use it. It's a layer 3 device. It's a network layer. Guys, root means path. Router, both the ways people will spell it, but router, it is root. Okay, the word came from root only. Root means path. The router will show you the best path to reach the destination. Okay, here it is again. I've written that one. The router shows best path to reach the destination. Router uses routing tables to reach the destination. Okay, these routing tables are created manually or generated automatically. Manually means you have to tell to the router so how to send this forward this packet to which direction based on router connectivity. Okay. Another one is the automatically creating these routing tables using a dynamic routing protocol. So these are the dynamic routing protocols like RIP, EIGRP, OSPF, BGP, ISIS. These are the dynamic routing protocols used in different places, different sizes wise also. Okay, so this is about your router. Okay, simple. Internally in LAN, you have network, but when you want to communicate outside of your network, different logical network or different logical and physical network, you have to go through your router only. Different logical and physical network or different logical network you want to communicate, you have to go through the router only. So in this world, there's several routers are connected one to another one. So I will show you like this, guys. So as I said, best path selection. Now I'm trying to reach google.com. So www.google.com, right? So what is the ping command? Ping command use it to test whether I'm able to reach google.com or not, right? So google.com is outside of my network, of course, but just I want to show you something. So it is showing whether I able to reach google.com or not. Okay. Communication between my PC to google.com is clear. But how I reach this google.com? Every day we are opening google.com, facebook.com, whatsapp.com kind of stuff. But how you are reaching this google.com? It will be there somewhere in the world location, right? It can be in the San Jose, it can be in Singapore, it can be in somewhere. But how you are reaching this google.com, you can understand by using command called a trace RT. Trace RT. It will tell you how you reach the google.com. So what is the google.com IP address? First one is I am reaching my what is 192.168.1.1, that is my default gateway, my laptop to my default gateway. My gateway, my router to outside of my router means my ISP provider. Mine is Airtel here. From Airtel to outside again. There's so many routers are connected in the worldwide in a WAN communication. So it is another router IP address and another router IP address and another router IP address. So when I am going to jump from one router to another router to another router. Simply to understand, guys. So if in case I want to go to Visakhapatnam, I get into the train or a bus. So how I go? A train, for example. First of all, train goes up to and next station like Secunderabad. First of all, I have to go up to from my home to Secunderabad railway station. Secunderabad railway station, then I catch the train, then train will leave, the next station will come up, maybe something like maybe a Guntur, or Vijayawada, next station, next station, next station, right? So finally I will reach my destination. Okay. So to understand, like I want to reach some place. First of all, I have to move from my place to next place, and next, and next, next stop, next stop, next stop. Finally, I reach the destination. Which is a better one? Same example. Two ways are there. So one is like one is Khammam side, another one is Vijayawada side. Right? So two routes are there. Which route is better? Which path is best path? More number of whole routers should not be there. The bigger the line, highway line, big express line is there. Less traffic, big lines, number of stops are less. Based on that, these routing protocols will calculate and tell how to reach the destination. Okay. So I reach my destination. See it is. I reach my destination finally. But from my laptop to my router to that ISP router to some other routers, router. Finally, I reached it. So this is a trace RT. Trace RT will tell you how you reach the destination. Ping command will tell you so whether you are able to communicate with the destination or not. A trace RT will tell you how do you reach the destination. For example, I am doing a trace RT to my router. Nothing, just I'm first one only, my router only. So I reach my router. I want to reach to this particular thing. So first of all, I want to reach this one. First, I'm going to. Okay, so I'm going to facebook.com, guys. My Facebook, I will tell. So first of all, this is the Facebook IP address. It is in a different location again. Both Google and Facebook are not in same location. But if you see, the first one is it is showing. You can see from here. The first one, two, three, four. Remember the first one, two, three, four kind of stuff. Here. Okay, once completed, I will tell you. Because it's not moving from. So this is the eighth query. Number of hops are the maximum is 30 hops. By 30 hops, you have to reach the destination. Otherwise, it is declared as a unknown location. So guys, look at here. When I'm trying for a google.com, when I'm trying to check how I reach my google.com, so it is the first step is, and second, third, fourth, fifth, sixth, like this. Okay. And we'll see. Here I try for a facebook.com. The facebook.com IP address. But first one is same. First is my router. First of all, you have to reach my router from my laptop to router because it's a default gateway. Next, my ISP. So where that ISP thing? Okay, here it is showing different IP. Here same, but here it is different. Sorry, that is not showing here, but it is showing different IP here. Can you see 116, 119? So that is okay. So here almost all I'm out of my ISP routers. Then it is jumped to different routers. It is this is different data. This is different data. Okay. Similarly, so I'm removing this one. I started from my place, guys. This is my router. This is my Airtel ISP, and there is some ISP related. So here it is some google.com means I have to travel in this, and finally I reach it. For example, here it is a facebook.com. Again, this is the path is available like this. Then I will reach here. Maybe there is some other .com is something is there like a whatsapp.com is there. Maybe it will travel like this. Travel up to here, common, and then this, maybe like this. Okay, so it is a route only. So if you understand, you imagine like you start from your home and you want to reach the nearest railway station, or maybe bus stop, or maybe you want to go to some place with the different routes available and common routes, common between both the routes. For example, not an example, the common routes like from my home to Secunderabad is common route. From Secunderabad to some up to certain place, it is a common route. From here, maybe it will divide locations. Okay, this is about a trace RT command. So I told two commands. One is ping already you know. So second one is trace RT. What is trace RT command, guys? Will tell you how do you reach the destination. Next important one is modem. Next important is, guys, are you understand router? Use of router. Router is a intelligent device, works with a logical address, layer 3 device. It is a layer 3 device. Internetworking device used in both LAN and WAN communications. If we can connect it to the WAN network, we can connect it to WAN network via routers. We can connect it to WAN network via, and router shows to reach how to reach the destination, okay, by using routing protocols. Different routing protocols are there. Static means manually or write this routing information, and also it is automatically created using dynamic routing protocol. RIP, AIGRP, OSPF, BGP, ISIS is the example for dynamic routing protocol. Yes, this is a modem, modulator and demodulator. Modem means modulator and demodulator. So it's modulate and send a signal, and it receive a signal and demodulate and convert it. So in our network, so we have a digital signals. Our LAN network is completely digital network, digital signal. These signals cannot be sent for a very long distance, including we cannot reach up to ISP, internet service provider. We cannot reach up to ISP with your signal. So modem will convert to the analog, passes through telephone wires, so we can reach up to our ISP. Nowadays, not only a telephone wires, here we are all mainly using now fiber optical cables. Still, some places telephone type of wires are using to connect, but still now we are using fiber optical cables. So our LAN in our my LAN, my laptop or other laptop, other mobile phones, all are connected to Wi-Fi router. The router a built-in modem is there. It convert all the signals into fiber optical, and it forward those packets to this fiber optical cable and send. So it is. We're all connected with Wi-Fi, but originally data is sent through the fiber optical cable. So what is that modem will do it? So that is first point in the modem. Okay. Next one is there is something I've written that is FM radio related. If you are listening to the FM, then you tune to the FM, right? 104, 98.3, 98.3, 95.3, or something 93.8. Okay, different radio Mirchi, big FM. Okay, so different FMs are there. Recently, I found that Ratnadeep FM is also there. Okay, now it is FM. Normal voice signal is 20 to 20 kilohertz signal. So that voice signal is mixed in this high frequency but sending a very long distance. At receiving end, you tune to that frequency, so you will filter the additional frequencies. You can listen main signal. Just for understanding what is modem and what is modulator, demodulator. FM receiver is a demodulator device. FM sender is like a modulator device. Whatever it is, the modem make you connected to your ISP, internet service provider. So you have your modem in your home. So when you are connected to the network, so you are forwarding packets through your modem. Modem connected to your ISP. Very simple. Modem is connected to your ISP. Modem connects to your internet. So another sentence you can use. Because of modem, we are getting internet. Connects to internet means we are getting internet via modem only. What is it? I will tell you how it is. In modem, in generally, you have a separate modem. You can easily understand, or if you are going to the settings of your Wi-Fi router, also we can understand modem part. You can see WAN connectivity, LAN connectivity kind of stuff. So you can see Wi-Fi routers we are using nowadays. I am showing that one only. You can see here it is the WAN port. This is LAN port. What is this WAN port? From ISP, from Internet Service Provider, is giving a wire to you, and we can connect it to this WAN port. This is one kind of type. This is another type. You have a separate modem connection. You are getting a wire from your ISP that is connected to modem. From modem, once it is established a network between ISP to this. This is a connection from ISP, connection from Internet Service Provider is outside connection. It is connected to your modem. Modem. Now in modem, so we have a information like a username information. You are subscriber, right? So of course, so your username, password is there. So what I will do it, I send this information, username, password information to ISP. ISP verify your username and password. Bill payment is done or not. Yes, okay. Then they will give you internet. Once you are okay, then they will give you internet establishment. Okay. It will send username, password, connection identity. Yeah, connectivity identity is also there, like a PPP, PPPoE, VC, okay, VPC, MPLS kind of connectivity is there. Both connectivity, username and password sent to the ISP. ISP verified your connectivity and send the packet. So it established the internet. Now we are getting internet. So to the modem. Okay, so that is the main important. This is my modem connected to ISP. Now we have internet here. We have a internet here. So internet connectivity is there. Now you have a computer, for example, think like this. You have a computer and you connected to this modem, then you will get a internet. Then you will get a internet. That's it. Then you will get a internet. So your computer is connected to a modem, you are getting internet. That is not enough today, right? So you are not having one computer. You are having multiple computers. You have multiple computers, right? And all these computers you can easily connect with the switch. But there is a problem here. Internet connectivity only one IP address. This connection establishment, modem got an IP address. Modem got an IP address. WAN IP address is there. But these devices required multiple IP address. Like I have a three devices, means three minimum IP address. So you cannot get three IP address from ISP. You have to purchase number of device per IP address you have to purchase. You cannot get it. Okay, that is one reason. Second one is this internal part is LAN network. This is entirely LAN. This entirely WAN network. Outside public internet network. This is internally LAN network. I use a private IP addresses. Understand? Different networks. So obviously it is a different network. So what I'm doing is I use a router. Symbolic representation of router is like a round, but routers are not look like a round shape. Okay, routers are also box shape one. Look like a box shape, only symbol. Think like this. This is switch or a hub, router, modem. What happened? Router route between this LAN IP addresses to WAN, WAN to LAN. Okay, it route between this network to this network. Modem make a connectivity, the ISP, and modem given a connection to router. Through router, we are distributing internet to our devices. Okay, so this side one network, that side another network. Of course, router is a internetworking device. We can make a connection between these two networks. Okay, guys, understand up to here? Next, I have a wireless devices. I have a wireless devices. For example, I have a mobile, laptops, tabs. I have a tabs, laptops, mobiles are there. Wireless devices need a wireless access point. Wireless access point. Wireless access point. So we can connect from router or you can connect from switch also, no problem. But what is this wireless access point? Use it to connect. Use it to connect these wireless devices. Use it to connect these wireless devices. Okay. So here is a modem and router, switches, wireless access point to connect a wireless devices. This is called a simple home, sorry, simple office, or simple office, home office. Sorry, correct. That is the correct one. Office, home office, or a small office, home office. Small office, home office, simple office, home office also you can tell. Better is small office. Okay. You may get a doubt, sir. I am getting internet, but I never seen a modem, router, switches, wireless access point, kind of stuff. Guys, one more point. LAN and WLAN. What is the difference? WLAN means wireless LAN. LAN is LAN. Normally we know with wires and all. Okay. But WLAN, wireless LAN. It is also a LAN only, but wirelessly connected. So using a wireless access. So you got a doubt, sir. I never seen modem, router, switches, and wireless access point kind of concepts here. Of course, because nowadays we are getting a Wi-Fi routers. It connects both the things. Okay, your Wi-Fi routers. Understand your Wi-Fi router. The Wi-Fi router. It is not only a one just a router part. First of all, we can connect wireless devices like a mobile phone, laptops, kind of stuff. Okay, you can able to connect wireless devices wirelessly. You can able to connect it because it's a router. It is route between different networks. Okay. Next, we have a WAN connector. WAN connector. Either this WAN connector is directly it can be a fiber optical cable WAN connector, or it can be a normal ISP provider, normal WAN Ethernet cable kind of connector. WAN connector connects your ISP routers outside, but WAN connector from outside to inside, directly WAN cable is there. And there is a LAN cables on it. If you in case you have a desktop, connect desktop to this one directly. Next, in built-in modem. So like this is a modem part. because WAN connectivity, it is a modem part. And of course, this is your main router part. This is router part. Of course, it is having a wireless. So modem part, router part, switch part, wireless part. These are all combined into single Wi-Fi router, depends upon your Wi-Fi router. It is WAN port, LAN port, Wi-Fi. You want to understand much better way, guys. So go through the Wi-Fi router settings also. You want WAN port, LAN port. Okay. So you can check it anything like a D-Link, Wi-Fi router configuration. You can go through videos or how to check the Wi-Fi configuration. If in case you never seen any configuration, so then better to go once. See, look at here, guys. It's a client computer, means regular computer connected to your Wi-Fi. Green check mark means my laptop to Wi-Fi is good, but my Wi-Fi to internet means the globe symbol means internet. My my modem or a router to my internet is cross mark means there is a problem with your internet connectivity. Yes, here it is thing admin syslog system something like setup advanced tools status. You can see this is a setup for a Wi-Fi wireless mode D-Link channel something it is showing. Okay, wireless network setup wizard, add wireless network device, manual wireless network support. Okay. The WAN setup. See WAN setup, PPPoE, PPP is dynamic static something. This wireless setup, SSID, and there is a password. But really, this is not a good thing like to show you. Compulsory, you have to go the full set of settings. Currently, I do not have connected any useless any Wi-Fi one, so I can't show you. Okay, so this is a Wi-Fi setup, WAN setup, LAN setup, DHCP setup. Already I told guys, the WAN setup. So WAN setup, maybe you can see this. We are not setting up anything. This is good. The WAN access. It is different IP address. The same way LAN access, you may get a different IP. This is a wireless access. LAN communication, WAN communication. Separate is there. So try what we will understand. So it's a good diagram. It is. Go to the router to direct PC, and there is a power connection for your router. Okay. So I don't have any the this Wi-Fi setup kind of stuff. Not used one. So then if I have, then I'll try to show you separate. Guys, always very simple it is. Wi-Fi setup for connecting wireless devices. DHCP setup. DHCP setup to get an IP address to the devices. Either it is wired or wireless, you will get an IP address from your router because of DHCP setup. Wi-Fi setup to connect wireless devices. Okay. WAN setup to connect your ISP. Okay. WAN setup, like you have to give WAN type of connection, username and password is to establish the connectivity, and you will get a internet from ISP. WAN setup. Router by default, so WAN by connecting, you got some different IP, and it is routed to our LAN IP address. Okay. So this is LAN side, WAN side kind of stuff. LAN and WLAN side. Okay, small home, small office network. Nowadays, everything is enhanced. So these are the main important devices, guys. Firewall, I didn't told about firewall. And some commands I told. One is the command I told, that is trace RT. You know ping, you know trace RT now, and you know IP config, all also, you know, get MAC also, you know. Yes, another point I'll just, that is a one is an IP address related, IP address, MAC address. So what is the difference between IP address, MAC address, and what is the IPv4, IPv6? About IPv4 classes, and what are their default gateways, default subnet mask, network and host portions, and OSL layer is also there. There's big thing is pending, but I'll tell about a small thing about a firewall. So here is an example of firewall. See this. Where is the firewall is located also important. Look at here. This is a LAN communication. This is the WAN communication. The firewall sit there. So this is internet, firewall, and your private network. It means in internet there is a lot of packets will travel. Only thing firewall is the first importance of firewall is just try to understand. Okay, the firewall protect your network. For example, this is my internet. This is my local network. Okay, when I establish the network, so what happened? I send a packet through firewall, and I will receive a reply based on my sending. I send, I will receive. But if someone is sending directly, firewall will block your request. Firewall will block this. Drop the packet. It does not forward the packet to your network. Even the built-in firewalls, like a laptop having a firewall, like your operating system, laptop or desktop, built-in Windows Defender firewall kind of stuff. It is also same work, but your personal one. That is your personal. In organization, in a nation, we use a direct firewall. We use a direct firewall kind of stuff. In organization, we use a direct firewalls. Direct hardware firewalls. We use it. Okay. Means for entire one network, entire your local network, use a firewall. So that's the point, guys. It's a direct firewall means like I remember one joke. Okay, so like a direct current. So people think direct current means it's without any filtering of current or reducing of power. So they are giving a current. So when your word is direct current means it's a DC current, which is not our main AC current. Okay, like your battery current. Okay? So point is not that one. The point is, guys, here it is. Just I got this throat infection, mind is not working. Firewall is before your office organization network. You put a firewall device. So it is to protect your entire your network from incoming to outgoing, outgoing to incoming packets. See internet, firewall, your local devices. So when you are sending, it will filter and send. When you are receiving, it will verify and allow inside the network. That is the file. Even you can say like this particular network or particular website cannot don't want to receive inside, so you can block it. Or you can say allow only these particular devices, sorry, particular network or particular website. Allow only these particular things. then only it will allow that one. Both incoming and outgoing, we can able to filter the traffic. But in generally, firewall means, understand guys, when you are communicating to someone, firewall will let you to communicate in generally. So by default, firewall, you send a packet through firewall, you can send it, and you will receive the packet based on your request. You send a request, you receive a information, so you will receive it. This communication is there. But someone in the internet want to send a packet to you, the firewall will block your network because you are not asking, but it is coming on its way. Firewall will block. That is one thing. Next one is firewall in your laptop compulsory. You have to enable. So this is the Windows Defender firewall. Your laptop or desktop, in your home network, private network, no problem. But when you are connected in a public, compulsory these firewalls must be enabled. Okay? That's not a main point. So I will go to control panel, then from there I will open main settings, but I will open normal settings. It is private and guest and public network. I open the network. Okay. So if in case I am in my home, no problem. Okay? Yeah, not much problem. But if in case this guest or public network, for example, I went to a coffee shop, some places like McDonald's or some coffee shops, coffee days kind of stuff, you'll get a free Wi-Fi network. You'll get a free. These are all different firewalls, software and as well as hardware firewalls. This is Checkpoint, DFSense, Palo Alto, Cisco, 6. There are some hardware firewalls. Okay. So built in our firewall. So what is this? If in case you are going to this free Wi-Fi kind of stuff. So we don't know who is connected in the network. Not even a secured one. When you are connected in the public network, compulsory firewall is compulsory on. Otherwise, you are not in the protection. So anybody can able to enter into your PC, so they can damage your PC. Okay, that is the firewall. Easy to understand firewall in our organization wise. See from internet, lot of packets are traveling and try to get inside your network. What is the firewall will do it? Only the allowed packets will be allowed, remaining packets will be dropped. Okay? And also user send a request through the firewall. So firewall will understand that is user based request. It is may allowed. Okay, it does not allow the automatically packets from outside to inside. That is enough. The firewall, but you can get it. What is the firewall kind of idea? Is understanding what we discussed today, the devices, hub switches, routers, modem, firewall. Okay, tomorrow we'll see the IP address and the OSL layer. But first of all, I will start OSL layer. If possible, already you have this PPT. Okay, link is already there. So please read about a OSL layer and IP address related. Okay, today. So it is make more easy for you. At least some names you can able to think like you are here already. Okay, that's it for today, guys.